Welcome to my Kcse revision channel, Teacher James Marita, the World Boys High School. Kindly subscribe my channel, click the notification bell, such that you get notified once I upload new video. Today we are looking at Kcse revision chemistry paper 3, a very important part of chemistry, and practical is the backbone of chemistry. So we are revising the titration questions that was done in Kcse 2021. So in chemistry practical, you only need to go through the solutions that you have been provided for. You go through the procedure because the procedure will be guiding you what you will be doing step by step. Then come up with the result. You complete the table and you write the correct observation where it is required. So it is not about guesswork. It is about doing the practical and come up with the correct result. So in 2021, you have been provided with solution A. Solution A is 0.10 molar solution of monobasic acid. We have solution P, which is a sodium hydroxide. So we have this is sodium hydroxide, which is having this formula. We have that as sodium hydroxide. Then we have solution C, and this one is containing 10.0 grams of acid C per liter. In this case, this one is the mass per liter. What were you supposed to do in this practical? You are supposed to, or you are required to standardize solution P using solution A. You standardize solution P. This is sodium hydroxide with the solution A. You standardize a base with an acid. Determine the number of moles of sodium hydroxide that react with 1 mole of acid C. So when you are calculating the number of moles, here you need to recall the concept of mole concept in Form 3. And in this case, you recall the formulas which are used to calculate the number of moles. There are normally two major formulas. That is the number of moles you can calculate by, you take the mass given, you divide by the relative molecular mass, or in this case you can take the concentration. If the concentration is provided, we have the concentration in moles per liter, the concentration in mass per liter. So in that case you take the concentration times the volume given, then you divide by 1000. Those are the two major formulas that you need to recall in Form 3 for you to calculate the number of moles. Then what is the procedure? You are supposed to go through the procedure because it is guiding you on what you are supposed to do. You fill the purette with the solution A. So you take a purette. For those ones who don't know the purette is this one. So you take this purette and you fill it with the solution A. We are not doing an experiment now. You take that solution A, then in this purette you fill. And make sure that you will be able to read the values of this purette carefully. You will be able to read the volume. So, and again, pipette, using a pipette and a pipette filler, place 25.0 cubic centimeter of solution P. So this is the pipette. The pipette in this case is measuring the specific volume. So if there's this mark, there is a mark here. This mark is normally measuring at exactly 25.0 cubic centimeter. So this one is normally measuring an exact volume. So you take a pipette and a pipette filler, which I don't have it now, and then you place this solution P into a 250 conical flask. So we have this conical flask. Once you have that solution P of 25 up to this much, so you transfer it to 250 ml conical flask. So you transfer that content in this flask. So 250 ml does not mean that you start again measuring volume of 250. No. it is just transferring a 225.0 cubic centimeters of that solution from the pipette into a 250 ml beaker. Titrate and titrate solution P using a velocity indicator and record your result in the table. Repeat the titration and then in the case you complete the table. So using a velocity indicator, you will be provided with an indicator during the exam. We have different types of the indicators, but this one will depend on what the Kenya National Examination Council that requires you to use. So we have various types of indicator. We have this is the velocity indicator. So you can also have the carbonate indicator, different types of them. We have a universal indicator. We have this is a universal indicator. You can also have what you call the methyl orange indicator. But in an examination, it is only NEC that requires what type of an indicator that should be used during the experiment. Now, we are not doing an experiment now. After carrying out the experiment, you are supposed to complete the table. To me, I have already completed that table. What are the conditions for completing the table? The conditions of completing this table that the table must be completed with the correct number of decimal places, and the maximum number of decimal places cannot be above 3. So you will have one decimal place to a maximum of 2 decimal places. So the table must be completed well for you to score all the 4 marks. So for example, if you indicate here 0.0 and on the other side you indicate 0.00, then that one is not correct. If it is 1 decimal place, make sure you use 1 decimal place all over. If it is 2 decimal places, make sure you use the 2 decimal places all over. So after completing the table, we are supposed to calculate the average volume of the solution used. So calculating the average volume of the solution used, you take now the volume of a solution. So in this case, there is this part where we have the volume of the solution, which is found by the final purity reading minus the initial purity, and then now you will be having the volume of the solution in cubic centimeters. So suppose now that in this case you have 25.6, and then on the other side, instead of having 25.6, you will have, for example, 25.0. Then the 25.0 will not be averaged because it is not within the range. So you make sure that you only average those values which are within the range. So carrying out now the average volume here, it is just you have 25.6. So we have this is 25.6 plus, in this case, we have 25.6, then plus, this is 25.6. You divide by the number of experiments, that is the number of experiments we have with this 3, and this one we have is giving us this as 25, in this case, 0.6, then we have centimeters cubed. That is how you can find the average volume of the solution used. Calculate the number of moles of solution A in the average volume. This is now where you are supposed to recall the formula of finding the number of moles. So in this case here, in the average volume, the volume we have as 25.6 cubic centimeter. Then what we have been provided in this solution A, we have been given the concentration of this solution A. So we have the concentration in molarity as a 0.10 capital M. This is the concentration of that M. So recalling that formula of finding the number of moles, you just have that moles is equivalent to, so we have moles which is equals to B. It is the concentration, that is the volume, and then you divide